Hi. This is my first time to use this feature in Canvas. So let's see if it works. So I uploaded this Excel file for you guys to see. This is the homework solution that we had for last week. Okay, and remember the calculation that we wanted. We wanted to check how many panels are needed to carry this monthly load. All right. And so to carry this monthly load, first we do it to a daily load, and you see the formula is simply dividing the monthly load over the number of days. You get how much per day you require, and those the instant radiation for latitude plus 15, because that's what was specified in the problem. This came just from the table that we had at the end of the homework. Okay, all those number is for every month how much instant radiation is falling on latitude plus 15 roof. What this means the roof is not at latitude tilt, which is for Tulsa we know 36, right? But latitude plus 15 mean that 36 plus 15, and this particular is much better in the winter, right? Because the sun would be low, so then you need the panel to be tilted a little bit higher. Okay, so you will see those numbers are a little bit higher in the winter as compared to simply latitude tilt. Alright, so here is the rated power of each panel. He said the efficiency, combined efficiency of all the battery storage and conversion and the wiring is, and the inverter efficiency, everything is 85. So come the formula to calculate how much we will generate per from each panel, right? And what is the formula? It is the rated power, the 300 watt, multiplied by this number, the kilowatt hour per meter square per day, divided by 1000, because that is like one sun. Okay, multiplied by the efficiency. So when you do this for every month, you will find out how much each panel generates per day. Okay, why per day? Because I just use kilowatt hour per meter square per day. So if I want to find out how much per month, then I have to multiply this by the number of days in months. So I choose to turn the load into kilowatt hour per day, and the generated energy per panel also kilowatt hour per day. Could I have done this per month and keep the load per month? Sure, months and months, or day and day. Anyway, so both will work, but here is the load per day, and here is what is generated from each panel per day. So obviously now calculate the number of panels needed, you just divide how much you need per day and how much it will gonna be generated from panel per day. Okay, and so you look at all the requirement, and obviously this is the months that require the most panel. Okay, 33.1, which means 34. Right, and we will ask Andrew to check those numbers for us to make sure that we didn't make mistakes on them, but the answer is 34 panels are needed. Now for problem number 2, he said now find out how many batteries are needed for what? For storing 7 days of consumption. Okay, and then once you find how many, you find the cost. So how do I do this? Well, I have the daily consumption, right? Or the daily load. This is the daily load. So all I want now is find out the weekly or like how many kilowatt hour needed for a week of consumption. So I just multiply the load per day times 7. Okay, and you do this for every month. And now, okay, so this is how much I want to store. Now, how much kilowatt hour can each battery store? He said it's a 12-volt battery, 100 ampere hour. 1200 ampere hour, you multiply those things by each other, and you get watt hour, right? Volt times ampere hour, you should get watt hour. But I want kilowatt hour, and so that's why the division over 1000, right? So you multiply the volt times ampere hour, divide by 1000. So what is that? That's how much each battery can store, and this is how much you want to store. So how many battery set do we need? We divide this over this.